Welcome to Wales Tech Week 2021. Thank you to our partners. Enjoy the session.
Well, good afternoon, everybody. A very warm welcome to everyone joining us at Wales Tech Week 21 this afternoon. We're representing Tata Steel in the UK. And as an iconic and strategically important anchor industry in Wales, we're delighted today to have the opportunity to share with you very much a 21st century story of a 21st century business. And we're hoping that by the end of today, that those of you looking from the outside of the industry maybe will have a very different perception, maybe changing from a steel industry to a tech giant, which is why we've called our presentation that today. My name's Tim Rutter, I'm Head of Communications, and I'm really just acting as the host for all the experts we've got to talk to this afternoon. And I'll introduce those just in a moment. But just to give you a brief outline for those of you who don't know about Tata Steel in the UK and in Wales. Ours is a company that employs about 8,000 people across the UK. You can see on the slide there, we've got sites as far north as Hartlepool, significant number in Wales, and they make tubes and pipes and colour-coated steels and strip steels and packaging steels over in West Wales as well. Plenty more on the website if you want more detail about what we do and where we're active. But across the UK, we've got a turnover of around £2 billion a year. And products from Tata Steel, they end up kind of everywhere. Steel is ubiquitous, but it can end up in products as glamorous as the Principality Stadium, here where I'm sat today in Cardiff, right through to the BMW Mini has our steels in. It can be as utilitarian as the humble baked beans can or a JCB digger. And even now, as contemporary as in wind farms and electric cars, steel is everywhere. A very, very modern material. Of course, ours is an organisation that is steeped in history, and yet it's at the leading edge of technology, as I'm sure you will find out today from our speakers as they talk about what they're doing in our industry. Ours is also a group that year after year is voted one of the most ethical companies in the world. It's a huge privilege to be part of the Tata Group and part of that Tata brand, and their ethics run throughout not just Tata Steel, but Jaguar Land Rover, which is part of Tata Motors, Tata Hotels, Tata Beverages, which owns Tata Tetley Tea. We're an enormous global organisation, but as I said, one of the most ethical in the world. And ours in the UK and in Wales is a business that reaches out across the world, and yet it underpins the whole of the UK manufacturing supply chain. And it is necessarily down the middle of Welsh government and UK government agenda. No matter what their policy area is, we have a contribution to make, and whether that's in employment, in energy, in community skills, innovations and technology, the sort of stuff we're talking about today. But of course, Tata Steel is very much more than just an organisation or just a company. For most of us who work there, it is a family. For many of us, it's a second home. And of course, it's the lifeblood of many of the communities in which we operate. So we're here today to represent the steel industry in Wales, but maybe not as you know it. So it's my great pleasure to introduce our three speakers today, in order in which they'll be speaking. Kevin White is our Process Control Manager based in Port Talbot. Rosie Hines is our Advanced Analytics Project Manager, again based in Port Talbot. And from Shotton in North Wales, delighted to have Tom Yehya, Software Engineer on Plant Asset Management, talking about digital twinning amongst some other things. Listen, do please feel free to ask questions as we go along. There's a chat bar on the right-hand side. Whether we get them as we go along, we probably save them to the end where we've got a Q&A session. Stephen Barclay, our Manager of Information Management, who's chairing this session, will host a panel at the end to answer those questions. So hopefully that all works okay. So I think we've got about an hour, just under an hour after my introduction. So what I'm going to do is kick off and introduce Kevin White, to run his session for about the next 15 minutes. Kevin, over to you.
Thank you, Tim. So we're going to spend the next 15 minutes talking about sensors. It's a light-hearted session. We're not going to be going through all kinds of painful engineering detail, but hopefully you'll get to learn a lot about how we use sensors, what we use sensors for, why and how we generate so much data across the business. Next slide, please, Stephen. There we are. So give you some context. For those of you who've not had any involvement with the business, you can see there it's a really large site, wide range of different environments, from a harbour and wide open spaces of stockyards, very large factories, steel buildings with all kinds of noise sources that would affect sensors. As well as that, you've got the sheer geography of the site, the fact that you've got to connect signals across miles and miles of open land. You can imagine trenches, cabling, roadways, railways. Very, very challenging environment to be installing sensors and making the connection of sensors back to the systems. So it's an unusual context. There's not that many sites that have the similar challenges that we face trying to get sensors all connected back into one intelligent system. Next slide, Steve. Next one, please. Thank you. So I'm sure not that many people still have the perception that this is the steel industry of today. The steel industry clearly has moved on. My grandmother worked in tin works back in the 1930s, and I wonder whether it was even like that back in those days. But certainly when I joined the business back in 1985, the world had already moved on significantly. And if we move on to the next slide, you'll get more of an idea of what 21st century steelmaking looks like and what it is we produce these days. So our customers, Tim mentioned a few, it's the likes of Jaguar, Land Rover, BMW, JCB. Their standards, their customer standards are obviously very, very high. And all of the equipment, all of the systems, all of the sensors that we use all need to make sure that the data that's fed into the systems create the most accurate, high quality products that we possibly can. So the steel making that we're involved in today is a very long way away from perhaps some of the preconceived ideas that people have of steel making. Next one, please, Steve. Okay, so here's a flashback. So I started with the business in 1985, and this was the system that was just being installed in our reheat furnaces. Now, in a lot of smaller industries, connecting sensors, connecting them back to computers, having display screens, that's all quite new technology. People talking about IoT and dashboards. But back in 1985, we had 5,000 signals there, all going back to that great big rack of computerized equipment. We had fully automated processes, and we had color screens for operators with no levers and any of the manual operations of the previous generation. So this was the first of this kind of system on that area. But people may not realize that the very first fully automated steel mill in the world was actually our Llanwern site in 1964. And there was a guy called Steven Spielberg, who you might have heard from the movies, and he didn't see his dad very much because he was actually commissioning that system. So it's interesting to think that perhaps the inspiration for getting involved in technology for Steven Spielberg actually came from his father's whole lifetime as a computer science engineer, and he was involved in some of the world-leading systems. And we were lucky enough to have one of those systems in our Newport plant, which really put that at the front edge of systems. So sensors, data collection, optimization, that's been in our blood for a very long time, even before the days when I joined the company. Next slide, please, Steve. So clearly what you just saw would have been tremendously expensive. Miles of cables, trenches, tray work, computers, input cards. Changing any of those things, very, very expensive, very slow, very difficult to organize and to arrange. That wasn't something you could easily scale. You couldn't suddenly flip it from one solution to another solution. And here we are to wireless sensors you can install in a matter of minutes. You can take the data from those sensors, you can configure them with your mobile phone or the Bluetooth, get those back to your dashboard in the cloud, and within a matter of minutes, you've really got a live working system. And all those things have become a very real possibility in the last probably 5 years. And harnessing those technologies in a safe and secure way is a key way of ensuring we've got a flexible and responsive system. Next one, please, Steve. So what can a sensor sense? This is a picture of one of our most recent lines, our automotive finishing line, which is down in our Llanwern works in Newport. What's really interesting with that line is it was designed with IoT in mind. So whether it's looking at the health of an asset, whether it's assessing the quality of the steel, whether it's understanding the lifetime remaining on pieces of equipment, we've got sensors feeding huge amounts of information back. So if you can sense it as a human, you can probably sense it with an electronic sensor, process it, digest it and work with it, and feed that into all manner of systems. And that's probably the next question. What the heck are you going to do with all this data? Where does it go? And what does it mean to anybody? Next one, please, Steve. So once you've actually got all that data, you've got to store it somewhere. And when you think about how much you've got to store, believe it or not, if you actually look at the number of sensors we've got, the frequency that we actually collect the data, in the course of a year, we actually store 1 quadrillion samples. I actually had to go and look the number up because it's not the kind of number any of us are going to use in our day-to-day lives, but 1 quadrillion samples of data every single year just across our sites. So that's obviously a really huge amount of data to manage, to store, to organize, and ensure the quality of. Next one, please, Steve. So you need to visualize that data. Different people are going to visualize in different ways. The operators need it for one purpose. The management need it for another purpose. And then Rosie's going to tell you a little bit later on about how we actually take large quantities of data, make sense of it, visualize it, apply mathematical tools to it, and actually get far richer insight than ever we could have managed in the past. So it's sensor data, it's business data, bringing all that together. That's where the value comes from. Next slide, please, Steve. So to give you one quite practical instance of where we might use this kind of data, many years ago with your car, you'd have a car broken down, you'd have repaired it, car breaks down, you repair it. They start developing maintenance schedules, so every 20,000 miles, every year you'll be changing the oil, changing the filter. Cars became more reliable. Now we're all used to the fact that there's a computer inside the car. Any of you driving an electric car is going to have even more insight into what's going on. It's going to know the mileage you've done, the temperatures, the speed, the way you drive, and it'll adapt then the maintenance all around that. And that's exactly the same concept you apply to a steelworks, is we'd use the same data to tell us what maintenance and in what circumstance needs to be done to maintain the asset in the optimal condition. Next slide, please, Steve. One thing that goes without saying is if you're going to be adding new technology, you're going to be adding to your attack surface. So it's critical that anybody thinking about adding sensors to their business, you need to know the provenance of the equipment, you need skilled people, you need to be assessing things properly, and you need to make sure you've got a secure architecture. So just simply buying sensors from eBay or AliExpress isn't the way for any small business to be thinking about using this kind of technology. It may seem like an easy way to get started, but you've got to say that sensors come with risk, and people need to be really conscious about how they go about using things in their business. So what's the message? Is IoT brand new? Well, we've had sensors for a long time. Is data storage or data analytics new? Not really. So what does IoT really bring? Well, it's bigger, better, faster, and more. So it just means you can do things more quickly, you can do things more cheaply, you can do things at a greater scale, and it becomes much more easy to do these things. So technology really has made the flexible, scalable tool we need to try and make the best of our assets, our equipment, and to fully optimize the plant without having to put miles and miles of new hardware in. So thank you for listening, and I'll hand back to Tim.
Yeah, that's great. Thanks very much, Kevin. And it does make you wonder where it's all going to stop, doesn't it? I remember when we were rebuilding blast furnace number 4 in Port Talbot Works, and the guys there were telling me how many thermocouples were going into the walls of the blast furnace, and I think it was in the thousands compared to the one next door of it, which had like 30 or 40. And you can't help wondering, A, where's it going to stop? But B, isn't it just something else to go wrong? No, it's like cars. They do everything these days, but you know, there's something else to go wrong, isn't it? There's something to be said for simple, isn't there?
I'm not sure, Tim. I totally take the point, but I think the benefits we get from the additional data and the flexibility of modern technology probably outweigh the benefits of simplicity, but you do have to do it as simple as is sensible.
Yeah, because I remember the thing with the blast furnace, for those people who don't quite understand it, is you can't actually see inside the blast furnace. You've got no way of knowing what's going on apart from the sensors, whether it's temperature or chemical makeup or so on and so forth. So it's essential in something like a blast furnace to have such sensors. And I I guess that's just the way it's going, isn't it? So listen,
Absolutely.
thanks very much, Kevin. If anyone's got any questions, please put them in the chat, and we can either take them as we go along or take them at the end. So that was Kevin talking about sense and sensibility. And I think our next speaker, Tom Yehya. Tom is from Shotton, as I mentioned earlier. Now, Shotton up in North Wales is one of the plants that we have that adds most value to our steel. So it primarily makes colour-coated steels. Tom may explain better than I can, but coil will be shipped up from Port Talbot, almost exclusively by rail, I think, these days. Where it's processed and coated and turned into some very high value construction products, which you'll see all over the country on especially industrial buildings, but more and more consumer buildings and more interesting coatings that are going on them. And they do sandwich sheets and profiles and stuff up there as well. So it's not a huge site, but it's a hugely innovative site. It's hugely customer focused site. And Tom's one of our more recent starters, I think I can say, without fear of contradiction, Tom. But we're delighted to have him as part of the business, and I can't wait to hear what he's going to tell us about augmented and virtual reality with digital twins. Tom, over to you.
Thanks, Tim. Yeah, so my name's Tom Yehya, and I predominantly do augmented and virtual reality at Shotton. So one of the things that you may be surprised to hear is I actually did a degree in computer games development. Go on to the next slide for me, Steve. Thank you very much. So a lot of people always think, oh, well, I just play games or I just make games. Well, serious games are part of Industry 4 in the form of AR and VR. They're really important to the success of any company. Being able to be hands-free, for example, with AR and doing maintenance on site with an expert on the other end of the phone is invaluable, for example. So, and I did a placement in Shotton in 2018. So that was sort of where I picked all of this up from in the beginning. So just to begin with, Shotton itself, as mentioned previously, we get all of our coils from Port Talbot. We have a hot dip galvanizing line and 2 color coat lines. And we have several panel and profiling lines on site. Occasionally we do sell hot dip galv by itself, but predominantly we send it down the color coat lines, and it is painted and made into panels usually as well. So just to go to the next slide, we've got some of the just an example of some of the places you might find our steel. For instance, on the outside of any IKEA you've been to, Cardiff City football grounds. We've also supplied steel for both the Shard and the Burj Khalifa, and DPD Cardiff as well, and other DPD sites. So chances are, if it's a well-known brand, it's probably our steel on the outside of the building. So slight brag there. So if you go on to the next slide. So just as a quick technical overview for what I do, it's essentially software engineering with graphics plugged in. Graphics is sort of a dark art in itself. We use lots of tips and tricks to make things work as fast as possible, which we'll go through in a couple of slides. And so, recent groundbreaking things have been things like real-time ray tracing, which is real-time calculation of direct light. That's billions or potentially trillions of calculations every second to find where the light is bouncing and where exactly it's going. So, these are really important milestones that we're reaching. So this is more of a technical side of things. But essentially, what we do is we pass a set of points and textures through to our graphics card, and that spits out what we see on our screen. And in AR and VR, we have to do that from 2 perspectives and 3 times faster than you would have to at what you would watch a movie at, for instance. And so it's really important that we understand the performance side of things. So just as an example on the next slide, you'll see on the left image, we've got actually a single polygon. Now, this is one of the tips and tricks. So this is one shape, believe it or not. The rivets aren't real, none of that's real. And on the right, you can see the middle busk has 6.4 million shapes or triangles, and the shape on the right has 1/1000th of that. So the real key here is by using our tips and tricks, we can bring that number right down in order to give the people who are undergoing, say, a VR training experience a realistic feel, so that they buy into what we're giving them and what we're serving them without compromising performance. and which will induce motion sickness. And so that's what we're really driving home here. So just in the next slide is what you might find. A lot of people get sort of confused between what a draftsman may do or someone who's more into the drawings and planning side of thing. Whereas for digital twins, AR and VR, you're talking two different worlds. You know, engineering requires incredibly high accuracy. You know, you have to measure things up perfectly, otherwise if they don't align, they need to be refitted. Whereas in virtual reality, we don't really care about that. What we really want is we want to make sure that everything feels real, that everything is smooth, that we can give people the performance that they're looking for. Because if we can't, we'll cause motion sickness. Just to give some rough numbers of what we're talking about here, a typical sort of Pixar movie could take 400 years for a regular PC to render. We need our PCs to do that 3 times faster, and we need to do it in real time. So that 100 minutes of movie that it might be for 400 years, we actually need to do in around 30 minutes, and we have to do it in 2 perspectives. So realistically, we're talking 15 minutes rather than 400 years. So we come up with various techniques in graphics to overcome these obstacles and do tricks that people buy into. And so if we go to the next slide, we can see one of the most basic examples of sort of engineering versus performance and 3D artistry. So in the red is 86,000 faces, and in the green is 3,250. So it's a 96% reduction, and they look almost identical. You know, if you were in a training scenario and this was in the background, you wouldn't be able to tell the difference. And so you can use these sorts of redesigns and refits of the existing model in order to really gain some performance from the hardware side of things. So just as a quick example, in the next slide, we've got a 3D model. It should spin. I'm not sure if PowerPoint will cope yet. So that is actually supposed to be smooth. This is just as an example of what we can do now. So that's actually one of the color code bays. And on the left here, we have the SPEC building. This we had a SketchUp model of. We put it into a game engine. We optimized it in several ways, mostly by removing or remodeling certain curved areas because they're really high complexity. And we then experienced it in VR, and the building owners were amazed. And on the right is the top of our galv furnace. It's an incredibly high area that we struggle to get to. You require gas monitors and so on. So you know, if we can reach that in VR, that's a much better environment to be able to experience that in. So AR at Shotton, we've really experienced a marked improvement in the way that we do things here. So we've seen improvements across the board, from safety, planning, maintenance, communication, and data visualization. And communication is really underlined because we've found that communication between different departments has really improved. If we continue to the next slide, it really does speak volumes. We quite literally give them the headset, and it's important to remember that white platform is not actually there. We simply use the HoloLens, and we take that model and we put it into the world, and we hand the headset to the people that are going to use this platform on a regular basis, and we say, what do you think of this? Can you give us some feedback? Do you have any concerns? Just as an example, with this platform, right away they said, well, now that we've seen it, we're worried about trucks potentially backing into the platform. And so before we even built the thing or did any sort of installation work, we immediately put a concrete platform to stop the truck from backing into the platform. So that it might not sound like a big deal, but if the truck hits that platform, we could potentially not be able to load any coils that day, and we may have some sort of real logistical nightmare building in the future. So it's really important to understand that how powerful a tool AR is in communicating things across to people who, you know, the drawing on the left really isn't very explanatory, to your eyes. So just continuing on to the next slide. So safety and planning, again, these are just some models that I've done work on previously. So this is actually guarding for one of the coater heads on #1 color coat. And this is we're putting guarding in on all of the lines as we continue, as our safety improves. So this is a really important thing, and more importantly, the commissioning has to be correct, because if the commissioning's not right and we have to refit it, we're talking thousands, not just a few hundred quid. So it's potentially tens of thousands to take this and refit it. So in the next slide, I'll show you what we actually did with the guarding. Again, we took the HoloLens and we took the guarding at a 1-to-1 scale, and we ensured that the guarding fit, which unfortunately, as the video is a bit slow, you'll see towards the end actually the design of the guarding on the far right hand side was too wide. So as you can see, it sticks into the wall. Now, the cost implications are massive. It's not just the redesign and the refit. It's the rescheduling of the labor, the transport costs, and so on. Something like this is really important safety-wise as well. So you may have to go through several forms in order to ensure that the guarding is still fit for purpose after the modifications. So we're talking potentially, if you're in a scheduled downtime window as well, it's really important that you do the fitting in that scheduled downtime, because you could again talk about extending that downtime, being down for longer, and you're talking tens of thousands of pounds. So it's really important that these things fit, and AR has proved invaluable for that. So just onto the next slide, and the other area of improvement we've seen has been in training and maintenance with AR specifically. So we're starting to develop tools now. This was one of the very early things that we put together, especially to do with inspections. So we tend to require both hands to do an inspection, not just for practical reasons, but for safety reasons as well. You can't be using one hand and possibly off balance. You need both of your hands. And so the HoloLens here and headsets as well, AR headsets, just really step into their own here. You're talking orders of magnitude safer than even things like paper, where you're not aware of your surroundings. When you're looking down, you may look up and knock your head. So things like wearables are really making a strong gains in this area. And we can do step-by-step things as well. And with built-in logging, we can log decisions as well that the people have made, and we can potentially review those decisions and ask them, why did you make that decision? Because it may be correct at the time, but we may have standards that say differently. And just to sort of look into the last area really for us of data visualization, so building on what Kevin and Rosie do, if you just hop to the next slide for me, we predominantly want to get what they're doing with sensors and data out of their world if we can, and into sort of our world, if you like. And so with wearables and our phones, we're building a system where you'll be able to simply scan a QR code, which will open a link to an app that we'll make, and that will essentially go into Kevin and Rosie's world and pick a value from a database, and we'll be able to display that in real time with real-time updates. The delay will be minimal, maybe up to 1 second, but for things like vibration analysis and things like that, we can go on site and audibly hear the problem potentially, and it'll save us either a trip back where we could actually come back and it's failed, or calling someone and that delay. We can just be on site with that immediately and find that value on site. So that's a really important step forward that we've had as well. And as far as digital twins are concerned, they are a true digital twin would cost millions. You would need a large team of developers to run that, to make that the logic involved in building something like that, to make a one-to-one representation with the physics and the science behind it, is a massive cost. And on the scale of our lines, it could potentially be an 8-figure sum. So these tools, we've seen, like I said, mentioned earlier, the graphics side of things have developed massively. I have no doubt that the digital twin side of things will develop massively too, and that cost will probably be 10% of what it currently is, and within 10 years it'll be on everyone's roadmaps, and it'll be very achievable. So that more or less sums up my side of things. So if there's any questions, again, please drop them in the chat.
Yeah, superb, Tom. It is absolutely extraordinary the work you're doing, and people like you in our industry, and how things have changed over a relatively short period of time. Because it wasn't that many years ago. I remember in the main offices in Talbot, we had a whole floor full of drawing boards, and I wonder how long it's going to be before people like you outnumber our, maybe our planning engineers or our projects office. Because is there anywhere this isn't applicable, Tom?
Not off the top of my head, I can't think of anywhere. It really is applicable across the board. The planners are still required. We definitely 100% need people planning. It's just the way that they plan will be different. The way that everyone operates at work will be different, and we're already seeing it now, like you say, from whiteboards to digital planners. So it's happening. It's taking time, as industry does.
Yeah. And it is extraordinary. And I know that you mentioned safety quite a lot, which is critical in our industry. And I know, for example, we're using drones a lot to do inspections in places that aren't easy to access, or that have some hazards, as you mentioned, about potentially gas on top of your galv lines and stuff. So you see, it's a speed benefit, it's a cost benefit, it's a safety benefit. And it's fantastic the work you're doing. I'm sure there'll be lots of questions for you. Listen, for the time being, we're going to say thanks to Tom and come back to you at the end with some more questions probably. But we're going to move on now to our third speaker. Third speaker is Rosie Hines. Rosie is based in our Talbot site and works with a team of advanced analysts, I think would be fair to say, Rosie. Now, I met Rosie personally first time a few years ago when I think Stephen Kinnett came to visit the plant, and we had this row of youngsters lined up describing their qualifications, and it was a list of qualifications I'd not really heard in the steel industry before. We're used to having engineers and operational specialists, but to have computer scientists and gamers like Tom and mathematicians is a breakthrough for our industry, and proving their value every single day. So Rosie, without further ado, I'm going to hand over to you, and you can baffle us all with your science, if you would.
Thanks for that, Tim. So yeah, as Tim alluded to, my name is Rosie, and I manage the advanced analytics team that's based in Talbot Steelworks. I started in Tata Steel about 3.5 years ago as a technical graduate, and as Tim mentioned, I was a mathematics graduate, and I was one of the first of my kind. So yeah, while you might think that Tata Steel is a company that employs engineers and chemists and things like that to work on their shop floors, new skill sets are becoming more and more sought after, with the newest being data scientists and mathematicians. So I'm going to talk to you a little bit about the work that myself and my team are doing, and how we're able to use some sort of more modern methods to influence change into what is actually quite a traditional process. So first, if you want to go to the next slide for me, Steve, I can give you a little bit of context into the world that we're working in. If you just click on once for me. Kevin gave a really great insight earlier into the sensors and how we use them to collect data. And this is just a process flow of our steelmaking process right up to where we cast into slab. So that's just before we roll it into coil, which is the image you're probably more familiar with, if any. We call this a heavy end, and this is the area that we cover. Each icon here represents a plant or a process or a part of our works, each of which has hundreds and thousands of icons of sensors that come with hundreds of thousands of data points as well. Each of the arrows is a form of transportation, be it train, be it road, be it conveyor belts, each of which also bring their own wealth of data points. So what can't be seen here as well, and is worth pointing out, is the huge and probably the biggest part of our process is energy. We generate a lot of our own energy on site, which is distributed in the form of electricity and water and gas between all of these different plant areas via various tubes and piping. And that's all done while maintaining quite a delicate balance. So if you want to just click once for me, Steve. So this process and the sheer quantity of data can seem actually quite complicated and overwhelming, but for a data scientist, it's an absolute goldmine for people who are trying to work and improve on the process. So it's really important as well to note that when we take in the process and we pick one part to start pulling some levers and make some change, you have to think about every other plant area. It's really important to create a kind of harmonious stream of advice, so you're not making a change in one area that's going to affect another. So it's really important that from start start to finish, we take all of that into consideration. So enough of the introduction. What actually do me and my team do? If you want to click on for me, Steve. So we use all of that data to develop machine learning models to help us understand our process. And to do that, we use data scientists, data engineers, and also optimization and simulation experts. And all of these people come together to do environmental predictions, make financial improvements, optimize on our material usage. Data governance is a really big part of what we do, and working on the stability of our process. So using technology like Python and Gurobi, we're able to use methods like decision trees, random forest, multilinear regressions, and even some deep learning and neural network techniques as well to gain some insight. So I'm just going to give you a couple of examples for each of these that we're working in, if you want to go to the next. So first up is financial improvements. So while most of the work we do to improve our plant efficiency will give a financial benefit, some of the projects that we do are kind of specifically to target a benefit and a saving, which is obviously quite important for a competitive plant. So in our steel plant, we take liquid steel, molten metal, we add in a mix of scrap and fluxes, and we do this to gain the right chemistry before we cast this into slab. It's important that the chemistry of all of our grades of steel are met to suit the suppliers, and that comes into play here massively, as everything we do has an influence on everything that happens downstream. So these fluxes and additions, they can be quite expensive. And up until very recently, our plant operators would use a certain set of equations in what we call our charge balance model to work out how much of everything we need. So how much of material A, how much of material B. By using machine learning, we were able to develop chat plots like you can see here to identify key influencing variables. And we actually use that to develop a brand new equation, which we've inputted into the CBM model. And this is to ensure that we always use the right amount of material. So this means we're avoiding using too much and overspending on excess, but it also means we're avoiding putting in too little and not achieving our target chemistries that we need to make the steel that we're trying to produce. So it's really important. And there's also a process to build that in. So again, normally a manual process, we're trying to optimize that and automate that as much as we can, which streamlines the process. So that's a financial improvement. Another benefit to machine learning is being able to understand and stabilize our process. So in our blast furnaces, for example, one of our metrics to measure instability is thermal control, temperature, and a measurement for temperature, a proxy, if you will, that we can use is our silicon level. So it just gives us an indication of where our stability is. It's a really key indicator of that thermal level. So through analysis of minute-by-minute data coming from all of these sensors that Kev referenced in his presentation earlier, over the last 4 years, the team have developed a tool that gives plant operators a prediction of how the process is likely to change in the next 2 and 4 hours. So previously, when you're controlling the process, which is still human-led, it's up to the operator to decide when he feels we need to add more heat or take heat out, or not add any additional heat, if that's the correct way of saying it. And the prediction now, using real historic data and combined with sort of very widely used predictive algorithms, can give them a basis with which to make very informed decisions. It's a well-built and accurate model, and it helps them feel a lot more confident in the decisions that they're making without the risk of causing any further instability. So it's really important, and naturally will come with its own financial improvements as well. A stable process means a predictable process. So the next slide will talk a little bit around different types of projects. So the first one being environmental predictions. So the models that we build here allow us to look ahead and ensure that as a site, we're adhering to all of our environmental obligations. So in the case of our boilers, one of our main sensors for emissions measurement was damaged, and during a time of COVID, it was very difficult to bring in people from overseas to come and repair these, and it was very difficult to travel. So thankfully, the skills in the team meant that we could make a predictive model that gave a very accurate reading of what our emissions were going to be, and it was so accurate, in fact, that the NRW accepted it as a model and a form of reporting data, which meant that we are able to safely continue operating as a plant, be confident in our process without breaking any restrictions with COVID and putting anyone else at risk. So we've done that for our boilers and energy. Moving on to the next, this is a slightly different project. So in addition to machine learning and prediction modeling, our team also takes on optimization and simulation projects. So in the last year, one of the team members took on the mammoth challenge of making a tool designed to provide a blend of materials for use in our coke ovens. This has been utilized in other areas of the plant as well, but this is the first one that we attempted. And the aim is to satisfy financial constraints. You always want to make sure you're using the best value material, but also you need to satisfy technical constraints as well. We need a high quality product to be able to follow through to our process as the coke that we make here goes into our furnaces. So it's all very important how it all links together. The inputs for this model include material properties and chemistry, financial value, and availability, which it reviews, it takes everything in, and it creates a global optimum, which means it's the best solution possible to suit a set of sort of predetermined parameters that's set by the people on plant. So the people who are running the process day to day can use this. The output of the model then, it gives guidance not only on the blends we should use, so what best mix of materials we can put together, but also how to use them, including the best way to phase materials to avoid any disruptions and avoid stockouts as well. We bring a material from all over the world, and it's very important to maintain a balance and make sure that we're not left waiting for a material that's coming from, for example, America. And that's a really important thing for our plant. So this work was based on an Excel model that was very good, but with software like Rosie and rebuilding and upgrading the model in C#, we're able to make a smooth deployable tool that is very easy to update and very easy to use. So this job is normally manual, developing these blends, and this frees up time and resource, which means these plant-based people can spend more time out on plant building and making improvements. So the benefit's twofold. It's not only financial with the materials, but also gives people time back, which is always important. And finally, on governance then, so oversight. One of the most paramount parts of any of the projects, any of the things we've talked about today, is the data behind it. The development of a top-class reporting tool, it gives us complete transparency of our data and full documentation of all of our variables at all levels of our business. And this is used from the operators right up to our executive committee. Everybody's looking at the same number and is agreed on what they're seeing. Without the data maturity that we have and the oversight has given us, we would be really struggling and unable to do a lot of the development work that we've done to date. So that's it for the examples. Just to summarize, really, the work that the group has done, and I speak for everyone on the call with that, has allowed us to completely modernize the way we're looking at the steel making process, especially in the heavy end, as that's the area I'm most familiar with. And it allows us to make use of sort of modern technology, which means we can tackle bigger and more complicated problems the more advanced we get. And more importantly, it helps us unlock values in ways we previously would have probably thought impossible, that you could predict the thermal stability of your furnace based on data. It's really important. And with the world moving towards automation in Industry 4, I think it's really important that we at Tata Steel remain current and right at that forefront of digitalisation. Thanks, Steve.
That's super. Thank you very much indeed, Rosie. And I guess, you know, in the olden days, people used to say steelmaking was as much an art as a science, but that's no longer true, clearly, is it? But how important is it to engage with the teams and make sure the guys at the shop floor are engaged with this sort of analysis of the data and understand what to do as a result of it? How well engaged are they with it all?
Oh, it's absolutely at the forefront of what we do. I think it's really important to mention, actually, that what sits behind all of this data analysis is experts, people who know the process in and out, spend every day out on that plant. They really know the data better than anyone. It's very important, but I think what data analysis allows us to do is have people who've not been in the business very long at all, have mathematical backgrounds. We're able to challenge on a very equal playing field because the data gives us the facts that we need to be able to have really level conversations with these experts.
Yeah, and I know you're involved in the heavy end, as you mentioned, but I guess this similar sort of activity must be happening through the mills, because you talked about environmental performance, safety, stability of the assets and so forth. But I guess at some stage that will knock on into product consistency, product quality, customer satisfaction, will it?
Absolutely, absolutely. And I know that there's a community starting to build, Tim, if that's the best way I can describe it, across our works, of people who are really paying more attention and starting to learn that these technologies are very accessible. I'm not going to say easy to use, because it takes time to learn them, but the more that we hire these people, we're talking about bringing in mathematicians and data scientists, the more we're able to do that as a company, and we are, the kind of more widespread this is going to be.
Yeah, absolutely. Listen, thanks again, Rosie, for that. Fascinating as ever. I think kind of we're about bang on time at the moment. I think we're doing quite well. I'm going to hand over for the next session to Steve Barclay. Steve's our Manager of Information Management, and he is going to pick up the questions that have been asked in the box. And please keep asking any questions if you've got any throughout this session. But Steve, maybe you could pick up some of those questions and pose them to the group.
Thanks, Tim. And I think really good feedback from a few people already. We've got one about IoT, and I think that's probably best for Kev to start off talking about where you see the growth areas. But I think Rosie in particular might have a view on where she'd like the next level of sensors coming from, to provide her with some more information. So, Kevin, have you got a view on that?
Yeah, sure. I think you've hit a really good point there, that where we need to use the sensors is where the business is going to get value from the data. So the challenge from the engineering side is to find the technology that makes it possible to give Rosie and the guys the data they need in the areas where we might not currently have it. So some of those challenges will be things like power. So clearly having available power on maybe moving machines is a challenge. And we're currently restricted by battery life, which means we might only want to take a sample every hour or every week or every day, just depending on the nature. So there's a lot of energy harvesting technologies out there now, which allow us to actually power the devices on vibration, on radio frequency energy, all kinds of things, which may be existing in the area temperature. All of those kind of technologies will allow us to put sensors in a maintenance-free place that we can leave for a very long period of time without needing to go out changing batteries or replacing the units. So I think there's a lot of growth in that area, which means you can kind of embed the sensor technology into a massive range of equipment. And also, as it becomes more cost effective, you're putting sensors in places you wouldn't have chosen to invest in previously. So you may have on a complex system wanted to monitor the pressure, let's just say in 5 places, or back to Tim's comment earlier about the thermocouples on the blast furnace. Years ago, we could only afford to put 30 thermocouples in. Now we put in thousands of thermocouples in. So I think the coverage is what's going to happen, is you're going to extend the coverage. You're going to have far more dense information, far more granular information, but also the kind of sensors that were difficult to roll out and embed previously. I think technology is going to be much, much easier to get that data for the people who need to consume that data to really make a difference to the business.
And you touched on connectivity there, and I know we've been looking at some proof of concepts on LoRaWAN, and we've got one actually in production now, I think is in the Newport plant. That allows us to have that easier connectivity over quite remote areas.
Indeed, there's a range of different connectivity options, wireless connectivity options, and each of them have different trade-offs. So 5G, for instance, would give you really good latency and the ability to stream vast amounts of data, be it video or whatever you need, but it needs a more complex chipset, and it's more power hungry. LoRaWAN gives you the opportunity to put really low-cost equipment out there into a wide range of areas and run on very low battery usage on a long period of time. So you're absolutely right. It's about having the right technology solution for each of those challenges, really, and having all of those tools at your disposal to deploy in a sensible, structured way.
And an interesting, we've got some new sensors that have been put on plant using Vortex's mesh technology for environmental monitoring for our site. And that's another connectivity method that we have got in place, but we haven't decided to go whether it's all the way across our plant yet. That's another way in which we can link up into a mesh of connectivity.
Absolutely, that uses the thread protocol, which is ideally suited to a self-healing mesh. So rather than rely on single points of failure within the system, each of the various nodes will talk to all of the other nodes within its area and manage multiple paths back. So if one system needs to be taken out of service to be maintained, then all the others will route the data around the missing unit, and that basically gives you a not quite an autonomous, but it's certainly a self-healing system that doesn't have the single points of failure that maybe more traditional systems such as a single 5G mast would have.
I think Neath and Port Talbot Council have now started fitting those on lampposts around Port Talbot. They look a bit like alien stormtroopers do. It's a bit fiendish, some of them, but it's good to see that actually coming out of our plant into the public.
That's right. They were actually designed as a custom project with ourselves in Vortex, and they're now, I think they're in the Midwest, in the Middle East. Certainly, the local authorities are using them here. They've been used in quite a number of places all over the world. So it's great to work with a very local and very energetic young company developing IoT solutions.
Another question here about edge computing. Probably another one for yourself and myself, Kev. We certainly have edge computing. What is your view about our current footprint and perhaps our way forward?
It's a really interesting one. The way terminology has changed over the years. If you go back far enough, we had centralized computing with mainframes, and then we had decentralized computing with personal computers and PLCs and things. And then the cloud came along, which was very much centralized computing again, a bit like a mainframe used to be, if you like. And now we're putting computing power close to the process edge computing, but edge computing never really went away. What's different now is the ability to run in a joined up way the same workload in the cloud as you can now run down in the plant. And that's the really interesting part, is how do you get that technology capability from the cloud and run it seamlessly at the plant or in the cloud. So we're working very closely with our Dutch team in their hot mill. So we do have an edge node there which we're trialing. So we have many edge systems that are autonomous, but we are also piloting an Azure edge system which allows us to kind of seamlessly extend the cloud down into the works area for where we have really high workloads and don't necessarily want to send all that data to the cloud just for processing.
One of our key cyber controls, I think you touched on at the end of your session, is about allowing our distinct manufacturing areas to operate for a period of time should we decide to close down, shut the shutters in a view of a cyber attack. How does edge computing feature with that? Because obviously we still need to have some connectivity for that.
You're right. There's a very a complex set of tensions, if you like, between priorities in that area. So there's various mitigations you can do within the IT side of things to maintain that connectivity with private links and things. But it's really a trade-off between the criticality of the service to the enterprise sort of ongoing business continuity, if you like, compared to the facilities which are more long-term and don't have an instantaneous effect on the business. So deciding what runs where, what its criticality is, what its backup processes are, what its layers of protection are, that's all part of the decision-making process about which tool to use in which job. And I guess that really leans on Nick's question as well about how things are not guerrilla systems and how we end up having a structured approach of tools that are for specific purposes. And we understand how to deploy those tools in a well-defined and structured way. Because as Nick said, if any company was to suddenly start buying all kinds of technologies from all kinds of places, they'd find themselves in a really difficult situation. So it does need to be done in a very structured way. Otherwise, you risk opening yourselves up to all kinds of unnecessary risk.
Cool. Tom, Rosie, conscious I'm talking to Kevin quite a bit. Anything you wanted to add in for those questions or anything we've covered so far?
I think from my side, if I can, it's really interesting to see as well, because one thing that we do know is there's so much data. Yeah, we've talked about the quantity, the sheer amount of information that we have, and sort of one of the things that the team does here is work out exactly which sensors we need to be pulling from to get the right information. So I think that's something that, again, you know, Nick's mentioned about bringing in a lot of information and a lot of data. And I think it's really important the way that we are engaging with all of the works areas to make sure everyone knows exactly which sensor is doing what and where to get the right information from. Yeah, the more complicated your process gets, the harder it'll be to model from a machine learning perspective. You know, when you think of something like Google Maps, it might take in a handful of variables to make a prediction. You know, we take in thousands to start with, and it's about narrowing that down so that we're looking at the right variables. So the more information we have, naturally, it's always better to have more data, but it's important that you understand that data and kind of build that across the board, which is what we're seeing.
I think sometimes people think you can never have too much data, but I think if I understand your processes correctly, I mean, a large amount of the time taken for any of your sprints is around collecting, curating, sifting, cleaning, cleansing, and selecting the data you need. Cool.
Absolutely. It's very an 80-20 split, where 80% is gathering the information that we need and 20% is doing the sort of magical algorithm stuff that I've been talking about. Really, the bulk of the work is getting the right data that we need in the form that we need it. But naturally, the more we do that, the better an understanding we build as a department and the quicker we are.
Cool. Just the next question, conscious we've only got a couple of minutes left, is around the fourth industrial revolution. And I think we've got something here. So these are some shots that we use in some of our standard communication. One of the key elements that we work on is awareness of where we should be going, our digital roadmap. And so we've done some work on fourth industrial revolution and how we can move towards it. And we also found that when we reviewed all of our areas, we are somewhere between the third and fourth. We have areas of the plant that are clearly groundbreaking, and we've reviewed some of those areas in today's presentations that are already at the fourth industrial revolution, using data effectively, improving the decision-making process. And yet we also have ones that are barely out of the third industrial revolution. We have automation opportunities. We have ability to add sensors cheaply now to perhaps bring them into the fourth industrial revolution, but we are somewhere between the third and fourth, depending on the type of unit we are looking at. I know we've reviewed quite a few areas today. I'm not sure if they've got time for any more questions. Tim, is it worth you wrapping up?
Yeah, no more questions on the board. And I know it's a technology event, and I know I'm kind of within the company, but one of the questions that appeals to me, especially for Tom and Rosie, you know, relative youngsters in our organisation, newcomers in our organisation in the last couple of years, and it's exactly the sort of people we want to attract into our industry. And I think events like today's will show people it's a very different industry than we might have imagined. And maybe I could ask Tom and Rosie, each of you in the last couple of minutes, you know, what would you say to people like you, maybe going through university or coming through school at the moment, about the opportunities in the steel industry and the technology they can play around with here?
Would you like to start, Tom?
So from my end, if nothing else, I knew a lot of people at university who are particularly interested in games. For software engineers and games development students alike, it really is a more rewarding job, in my opinion. Game developers tend to be in it for the games. I didn't really subscribe to that. So, you know, if you're interested in software, then there's nothing better than to be at the start of it, because you get to direct it, you get to steer it, and you get to make it yours. And for me, I didn't want to be a big part of a massive wheel and, you know, start at the very bottom, if you like. I wanted to come in and immediately start making a difference and immediately start handing my knowledge over to people who could make those decisions. on a grandiose scale. So definitely go for it. You know, starting smaller and in a more tighter team tends to always lead to bigger things in the future.
Yeah, it is extraordinary what you've managed to achieve in a relatively short period of time, Tom, up there. And I know you've had some quite high-profile visitors that you've talked to as well. So you really be in the spotlight. Rosie, similarly, you know, for mathematicians and analysts, what would you say about the steel industry as an opportunity, as an interesting place to work?
What I'd say is, before I joined the steel industry, I didn't know how something like mathematics could fit in. You know, you think of it as, you know, a place for engineers, a place for chemists. There's a place for everyone. If there's something that I've learned, is there's a place really for any level of expertise, but specifically as a mathematician, this is the start of data science becoming really at the forefront, and it's similar to Tom's. Really is how exciting to be a part of that journey as it's starting up. So that's the kind of overriding thing, is if you're in a sector or you're doing a degree that you might not think necessarily applies to the steel industry, it probably does. It certainly does in some way, shape or form. And if it's technology based, then absolutely there's a place for everybody in that sector.
Yeah, super. Thanks very much, Rosie. So listen, we've come to the end of our time contract this afternoon. Hopefully those people watching who didn't know much about the steel industry know a lot more about it now. Hopefully, you know, we've changed your perceptions about our industry, that it is a technology leader. You know, we've got lots of these young people using the latest technology to develop our industry faster than ever before. Hopefully you've also got the sense that this is a group of people who absolutely love the steel industry, who love what we do. We have a great sense of family, a great sense of fun, and a great sense of achievement and pride in an anchor industry in Wales, and one that's critical to the UK manufacturing supply chain, and certainly as the UK develops into a global Britain, as the government will have us. It's been an absolute pleasure being here this afternoon. I'd like to thank Kevin and Tom and Rosie and Steve for hosting the questions. And thanks very much. And if you need anything afterwards, please do get in touch either through the technology guys or directly. Our social media feeds are on the opening slide, which I'm sure will be available too. So thanks very much for everyone for joining.
Thank you for watching. Rewatch all of our sessions online. Thank you to our partners,